Hello everyone, data structures, algorithms, insertion sort. Insertion sort divides the array in sorted and unsorted partitions. It then grows a sorted partition from the front of the array. The element in the index 0 is in the sorted partition, and the length of this array is 1 by default. It makes sense. It is only elements on this array, so it's also sorted. At each iteration, we take the first element out of the unsorted partition, we add it to the sorted partition, and the partition length grows. We compare the value we are inserting with this at the sorted partition. Now let's see an example. We have, for example, this array. We start at the first element, the element 18. And this element is sorted. This is our sorted partition. It starts with a length of 1. A length of 1 because we have only one element, the element 18. Then we compare the first two, the 42 and the 18. We see that the 42 is at its correct position because it is larger than 18. So the sorted partition becomes the first two elements, 18 and 42. Then we compare the third element. The third element is a minus 8. We compare the minus 8 with the 42. We see that the 42 is larger than the minus 8. So we swap them. Then at the next iteration we compare the minus 8 with the 18 and we see that the minus 8 is less than the 18, so we swap them. And now our sorted partition has the minus 8, the 18 and the 42. Then we compare the next element from the unsorted partition, the 4. We compare the 4 with the 42, we see that the 42 is larger and we swap them. Then we compare the 4 with the other element in our array, in our sorted array with 18, and it is less than the 18, so we swap them. Then we compare it with the first element of our array with a minus 8, and we see that the 4 is larger, so it is at its correct position. So our sorted array now is the minus 8, the 4, the 18 and the 42. So the unsorted partition that is left has two elements, the 60 and the minus 77. We compare the 60 with the 42 and we see that the 60 is larger than the 42. So the 60 is at its correct position. And the only element that it is now left unsorted is the minus 77. So we rise and repeat, we do the same procedure, and at the end we have the minus 77 as the first element, then the minus 8, then the 4, then the 18, the 42 and the 60. Now let's see some facts for the insertion sort. The insertion sort is an in-place algorithm, which means it doesn't use any extra memory. The time complexity is O to the n square, so it is quadratic, and it is a stable algorithm. Now let's write some code. Open up your Eclipse, IntelliJ, JetBeans or whatever you use, and the code implementation will be at the next video.